All right, welcome back. Thanks to everybody who came to the face-to-face session. And hello everybody watching online right now. Remember, we are live streaming on YouTube. Hopefully it works fine. Yeah, okay, I've got tone on my mic. Remember, we do have a live Q&A session going on Piazza. So if you, in the class as well, if you've got questions, you can go ahead and post those to Piazza. Under the live Q&A, because that's all I'm seeing right now. Once those questions have been answered, please go ahead and resolve them. For example, somebody already asked a question about hacks being graded. All hacks are graded within 96 business hours, meaning that when they're due on Monday night, the LAs have 48 hours to grade them, and then the course leaders have another 48 hours to do quality checks, and then we hope to release them by 5 o'clock on Fridays. With labs, we try to get those done the next day. And of course, with readings, those are done automatically. So every time you complete a section of your reading, it automatically pushes out to Canvas. Okay? Okay. So to continue what we were doing last time, remember that the last thing that we did, we didn't finish it up. We had this really quick exercise, and I don't have I have the mic, the internal mic on. Let me know if you can't hear in the back, okay? All right. So the exercise that we were working on last time was computing roots that we read in A, B, and C, which were coefficients of a quadratic formula, a squared or ax squared plus bx squared plus bx plus c is equal to 0, right? And the roots, of course, can be computed using the quadratic equation, right? The quadratic formula. And so we were just in the midst of testing this out and trying to fuzz it like you did yesterday in your lab, trying to give it some bad inputs to try to break it. So let's go ahead and try to break it again. Let's go ahead and try to fuzz it and break it here. Oops, sorry, there we go. All right, so GCC, I think it was roots. There we go. All right, first of all, lots of errors here. So we need to pay attention to warnings. Warnings are a good indication that there's something wrong. And if you're ignoring those warnings, especially if you hand something in and on the web grader it's giving you these warnings, those are going to be points off on your hacks. We don't take points off on that for labs, but we do bring that to your attention because we do take points off for hacks. So what's wrong with this first one? Line 24, what am I doing wrong? Anybody in class? What does it say? Format %d expects argument of type int, but argument 5 is of type double. So 1, 2, 3, 4, 5. There's the fifth argument, right? That's going to be the fifth argument, like right there. And I've got a double. What's the placeholder for an integer? %d. But this is not an integer. This is a double. What should the placeholder be? LF for scanf. For printf, we generally use just f. You might be okay with them, but it really depends on the system. Okay. Likewise, f over here because of the first root. But this gives me pause about my entire design here. When you've worked with quadratic equations, you've probably only ever worked with integers because those are the easy ones, right? But does it have to be integers? Can you have 1/2 x squared plus 3.2x minus 5.8? Sure, why not? So why am I restricting my coefficients here to integers? I'm going to go ahead and change those. Double, double, and double. Okay? Let's save that. Let's clear this again. And let's go ahead and try to do that again. All right, well, now I'm getting the same message down here about these %ds. F, F, and F. Right? But what else am I getting here? Let's see. Here we go. On line no, that's just line 24. All right. Okay, well, that's fine. Let's go ahead and do that. All right, so GCC again. All right, now we've gotten rid of some of those errors, some of those warnings. What's wrong here? Undefined reference to square root. Where is the square root function? In the math library. I've already included it, right? Remember the quirk. What was one of the quirks? GCC. Roots.c. What do I have to give it? What flag do I have to give it? Do you remember from last time? -lm. What does that stand for? Link in the math library. Remember that whole process whereby we had a source code, we compiled that into assembly, then we compiled that into, or we assembled it into assembly code, then we compiled it into actual binary, and then there was another process under the hood where we linked in all the standard libraries. The standard library, the standard input-output library, and here the math library. This is just simply a quirk of some GCCs the way that they're set up. So I have to manually say, please link in the math library for me. You can do it like this, but LM is just as good. Abbreviations. Oops, not roots. What is it? Root. There we go. And now it's happy, and I can run this. So let's go ahead and try with 1, 2, and 3. Okay. Are those the roots? This is my first test case, right? I'm trying to break this program. I'm trying to verify if this program works. So how do I know if it works or not? How do I know that those are the roots? How can I complete this test case? Pull out your calculators, right? Or pull out a nice, really powerful calculator called Wolfram Alpha, right? So x squared, what was it, plus 2x plus 1 equals 0. Find roots for me, please. -1 with a multiplicity of 2. Hey, it works. All right, oops, sorry, over here. Same. That's a test case. A test case is known input and known output. That you know that this input should produce this output from some other source, not your program. If you just said this oh yeah, that's probably -1 and -1, right? Let's move on, right? That's not a test case. You have to either pull out your calculator, do it on a piece of paper, or use another source to verify that that test case is correct. In fact, that's what you should do before you even write your program. You should set up a test case so that you understand the problem, that you have a known input-output pair, that's a test case, so that when you write your program, you can feed it that input. Does your program produce the same output, right? And that's what you should be doing for all of your programs. And you probably do it in an ad hoc manner right now. Whenever you write your program, of course, you run it at least once, hopefully, right? And with some inputs, and you say, oh, okay, well, it looks good, and then I'll put it in the grader. Later on, we're going to get into more rigorous ways of doing this with test suites, test frameworks, and all that stuff, okay? All right, so are you satisfied that this is a correct program? Well, let's try. What about 1.5? Oops, there we go. Okay, -1 and -1 still. Do you think that that's right? Should I get the exact same answers for different coefficients? 1.5 times, what does Wolfram Alpha say? In fact, what does that I tell you? They're complex roots. They're imaginary roots. Because the thing under the radical is going to be negative. Right? Oops, go back over here. Okay, so what's wrong? What went wrong? Remember, I changed my design. I changed my design to change these to doubles. Is this correct? A to I, what was that for? Integers. A to F is the correct one for floating point numbers. Once I've done that and I recompile, and I rerun that again, now I get nan and nan. Right? What does nan stand for? What do you think? Not a number, right? Why? Because the square root of something negative is I, right? Or it's I times something something, right? And so it's an imaginary number, and it's a complex number. We don't call them imaginary numbers, but we still use I. And a computer can't handle that. At least the built-in primitive types can't handle that. So what we need to do is we need to bring in a library or something else if we want to actually support this. There's a question online. You would use %LF for scanf generally. You could use potentially LF here. In fact, let's find out. LF and LF. But generally, you don't see that. And I won't test it with that one. I'll test it with the original one that I know works, and that'll still work. But for printf, you generally just use %F because it's going to be the same. Right? Why write more when you can write less? Okay. All right. So we've got a problem here, right? We already know that there's some inputs. Let's do some more fuzzing. Right? What could I do? I could make A very large. I could make B very small, and then it doesn't matter what C is. I'll go ahead and make that small too. Not a number, not a number, right? So what happened there? Complex roots. What's another bad input, right? We asked you to think about bad inputs in your lab yesterday to try to break the birthday program. What are some bad inputs for this program? Well, we've already seen some, right? Where you would have b squared minus 4ac ends up being negative, and so you have complex roots. What other? Remember the quadratic equation, right? Negative b plus minus square root of 4ac, b squared minus 4ac all over 2a. What else could go wrong? No? Well, what about this? 0, 1, 1. What's going to happen there if a is 0? What's in the denominator of the quadratic equation? 2a, right? So if I have 0 in the denominator, what is that? Division by 0. What's going to happen with division by 0? What happens in real life if you divide by 0? Nothing, you just move on, right? What happens in calculus if you divide by 0? Well, it's not defined, right? What happens in calculus if you take the limit as the denominator goes to 0? What happens to the value? It goes off into infinity, right? What's going to happen here? One of them indeed goes off to inf, or down to inf, negative inf in this case. What does that mean? What does inf mean? Infinity, right? So you do have some gotchas here that I'm going to start documenting over here, right, for miscellaneous. Let's see, where were we? Yeah, here we go. So take care of that some operations are invalid, right? For example, the square root of negative 1 results in not a number. Nan, not a number. Division by 0 results in inf, etc. Right? Another thing, again, that hyphen LM flag that we just talked about. This one I'll come back to in a second here. Okay? So, okay, how are we going to end up dealing with this stuff? We can bring in a library to start dealing with complex numbers if we really want to. Or we can say, well, I don't know enough about C to be able to do anything like that yet, so I'm not going to be able to handle that. If somebody tries to give me bad input, just like like you tried to give the birthday program bad input, February 30th, is that a valid date? No. So what should we be doing? We should be doing defensive programming and saying, if you give me bad values, I'm going to look at those values and say, I don't know how to deal with this. Throw it back at you, and okay, that's an error. I'm going to quit out of the program. Right? Just like we did with command line arguments. If you don't give me enough inputs, or you give me too many inputs, I'm going to quit out of the program on you. That requires decision making, which is what we're going to start talking about today. Before that, though, another thing that I wanted to bring to your attention is that C has no default values. What I'm going to do to illustrate that, let's try REPL. Right? We'll try both. I wonder what happens here. I'm going to go ahead and duplicate the print statement up here before I set those root values. All right, let's go ahead and compile this again and see what happens. Oops. Oh, okay, well, I'll have to declare them up here. Double root 1, root 2, and then I'll have to get rid of the declaration down here and set them down here. Okay, now I'm going to go ahead and compile this, and then I'll ask you the question. There we go. I'm going to give it good inputs, meaning I'm going to make B big. Remember, this was negative 1 with multiplicity 2, negative 1 and negative 1. What values does root 1 and root 2 have on line 22? So I declare them. I never set them. I set them down here. So if I'm going to print them, what values do they have on line 23 when I print them? I I don't know. See me shrugging? I have no idea. Let's find out. What happens when I actually run this? 0 and 0. Okay. That sounds reasonable. Let me go ahead and take it over here to REPL. That's still loading. Okay. Everybody likes REPL. Okay. There we go. All right. And there's my program. And we'll run this. Segmentation fault. I don't know why. That was weird. Oh, you know what? That's why. How do I do command line arguments? That's a good question here. All right, I'm just going to have to set these. I'm going to have to manually set these values. You don't want to do this in practice because then you forget that you left dead code in here. Let's go ahead and run this. There we go. Oh, okay, it's 0 and 0 over here. So what might you think is the default value based on just these two samples alone? That if you don't specify a value, maybe 0 is provided for you. That's only because we got unlucky with these two examples, and that particular compiler that was being used decided to go ahead and set those two default values to those values. Let me go ahead and try to give you another example. I'll get rid of all of this. Int x, printf x is equal to %d and the line x. There we go. Now this is as simple as it gets. I wonder what x. Come on, really? Let's see. Double y is equal to 3.114. Let's try this. Nope, still x. Okay, I'm not going to be able to force it. I forced it yesterday in the other section, but I'm not going to be able to force it today, apparently. So the takeaway from this is that C, in fact, has no default values. Uninitialized variables may not have a default value. If a default value of 0 is observed, that is entirely due to the compiler and or operating system. There is no default value defined for variables. That can get you into a lot of trouble. Because if you start adding stuff, like if you have a total variable, and then you add A, then you add B, then you add C, well, A, if it was garbage values to begin with, some random value, then you have a random value, garbage value plus 1, plus 2, plus 3. Well, garbage plus anything is still going to be garbage. And unfortunately, I'm not going to be able to reproduce it here, but maybe I can. I don't know. Maybe I can. Let's say int a is equal to 10, x, and then a is equal to x plus 5. Can I force it? A and A. Oh, okay. I'm going to give up now. But I was able to demonstrate it yesterday. But in any case, there is no default value. You're just going to have to trust me on that. Some programming languages do define default values. Usually the default is 0, but in the case of C, there are no default values. So if you start getting these weird values where you don't know where they came from, probably want to check your variables. Did you ever initialize them? Did you set if you're going to take a sum, where do you want to start that sum? At 0. Then you can add A, then you can add B, then you can add C. So keep that in mind as well. Okay? All right. Any questions online? So good question. Where does the LM flag go? And unfortunately, it depends on the system. As we've seen here with CS50, you put it at the end. I believe on CSE, on the CSE server, you need to go and put it after the GCC. Unfortunately, it's a quirk. It is how each individual compiler has been installed or set up. Okay? Some of them, like my Mac here, has been set up so that you don't need to do that at all. But I'm not working on my Mac here. I'm working on CS50 and REPL. Okay? All right. Any questions about the basics? No? No? Okay. All right, then. Let's start talking about conditionals because, like I said, that was the tool that we're going to have to use in order to do what's called defensive programming. You gave me bad inputs, or you didn't give me enough inputs, or you gave me too many inputs, right? I'm not going to do this operation because it would result in a division by zero error, or it would result in not a number. So I'm going to instead give you an error message or do something else entirely, right? Normally, programs have a sequential control flow, meaning that each instruction is executed top to bottom, right? One after the other. However, more complex problems require decisions. Now, this is not the decision as in you're trusting the judgment of the computer. It's not a decision as in you're asking them their opinion or anything like that. It's a decision on, given some condition, I should do A or I should do B, right? Conditionals are how you do that. Conditionals are how you can specify that code executes under one condition or does not execute at all. Or you can specify that under some condition, one piece of code executes, and otherwise, a different piece of code executes. Okay. The way that we do this in the vast majority of programming languages, executes, fix that right there. The way that we do this in the vast majority of programming languages are with if statements, if else statements, and if else if statements. Right? Now, actually, these are all the same type of statement. It's just whether or not you have an empty else in all of these things. Right? There we go. Okay. So conditionals usually, or they always, rely on some sort of logical condition. Right? Let's check online here. Okay, 63, not too shabby. What does the foo.c mean? I have no idea. That's just another file. I don't even see the foo.c. Sorry, I don't know what you mean. And that's been answered too. So I'll go ahead and resolve both of those. Okay. All right. So online questions. Conditions rely on some sort of a logical condition, right? So let's first of all talk about the basic syntax of these three statements that I just said: if conditions, if else conditions, or if else if conditions. And to do that, I'm just simply going to cut and paste one of them over. This is not real C code yet, okay? Because that Langle-Wrangle condition, that's not how you write conditions. We're going to get to that in a second here. But here's the basic idea. That if this condition is true, a condition is something that is always true or false, right? It can't be both. It has to be one or the other. It can't be some intermediate, well, it's half true and half false, or 75% true and 25% false, right? It's what's called a boolean value. It is always either true or false. It can't be both, okay? So the condition here, if it's true, then everything inside these curly brackets, that's called a code block, is executed. If the condition evaluates to true, then the code inside this block will execute. Otherwise, oops, I'll zoom out here a little bit. The block will not execute, okay? That's a basic if condition. You can augment that to specify that this piece of code, so the basic idea here is that this piece of code gets executed or it doesn't get executed at all, right? Only one of two things can happen there. Or you can augment that with an else statement. So now we've got the condition, and if the condition is true, then the first block gets executed. Otherwise, if the condition is false, else, then this block of code gets executed. I can zoom out again if we want. Oh, wrong way. There we go. There. And sorry, those are kind of difficult. Can you see that all the way in the back, even though it's grayed out because it's a comment? Okay, good. All right, so you can also have an if-else if condition, but we're going to talk about that here in a second. So an if-else statement is here's a term that you'll need to understand. Mutually exclusive, right? Meaning that exactly one and only one of the blocks will ever be executed, right? Never will both or neither, right, get executed. In other words, in the second one here, this one of these is going to execute. Either it's going to be the first one or it's the second one. If the first one gets executed, then the second one will not get executed. It mutually excludes the second possibility. If the second one gets executed, then the first one is never executed. They exclude each other. They're mutually exclusive, and that's that's what that term means. Let me give myself some more room here so that it comes up. There we go. Now it'll always jump to the center there. Right? You can also have more complex statements, more conditions, and more complex statements using an if-else-if statement. Right? Statements. There we go. Right? And I'm going to cut and paste this one over. Again, this is not real C code yet. This is just to give you the idea. So I've got condition A. What we're going to do, remember that we've got basically, we still have linear control flow. It's a sequential control flow where we start at the top and then work our way down. So the first thing we do is we evaluate condition A. If condition A is true, then we know immediately, okay, this is the one we want. And that first block gets executed right here. Otherwise, if it's false, then we go on to the next condition. Else if this condition holds, then execute this block of code. You can have as many of those as you want. You can have 50 different else if, else if, else if, else if. It's not great programming. It's not great style to do that. But you can have as many as you want. Otherwise, if neither one of these conditions is true, then this ends up being the default, and that gets executed. And once again, all three of these conditions are mutually exclusive. At most, in fact, exactly one of these is going to get executed. Either this one, or this one, or this one, but not any other combination of the three. Two of them won't execute, three of them won't execute. It's exactly one when you use all three of these things here. Okay? So the order is important. Order is important. The first conditions, the top conditions, or the conditions, I'll just say, are evaluated in the order you write them. Right? The first condition that evaluates to true is the only one that whose block gets executed. Right? Thus, all conditions are mutually exclusive. Right? They exclude each other. Only one of them is ever going to get executed. If no conditions are true, then the else block gets executed. Right? Else blocks are always optional. So if you want this condition, and then this action, this condition, this action, but you don't want any default action whatsoever, you don't have to put an else condition. In fact, if you have no default action, it's best not to put an else condition, and you just let the program continue its control flow after it's done. Right? So don't leave. Here's another term that you should learn: cruft. Right? Cruft is dead or useless code. Right? In your code base. Right? That should not be there. So what I see all the time, or especially from beginning coders, is that I'll have an if condition, if, else if, else if, else if, and then I think I have to have an else, because even though I'm not going to do anything. So they end up writing an else condition with nothing in it. And if there's nothing in it, then why did you write it, right? So that's dead code. That's useless code that shouldn't be there. It's called cruft. That's a slang term. It refers to either, I think, Harvard or Yale or something. There's a Cruft Hall that got a bad reputation because it just used to be this this unused building where people just dumped all their garbage, right? We have 50 overhead projectors with broken light bulbs. Where do we put them? Throw them in Cruft Hall. We've got an old copy machine that's broken. Throw it in Cruft Hall. And eventually it filled up with garbage, and it was called Cruft. Garbage that shouldn't be there, so that you should just throw away, right? Why are you keeping it around? And we use that in code now to refer to dead code or code that has no business being there because it's useless. Right? It's extra cruft. Question online: what happens if when the if and the number of else statements are false? In other words, what happens when the condition input doesn't fit any of the conditional parameters? Then the else condition will take over. If there is no else condition, then the program just continues normally after the if-else if. All right? All right, so let's take a look at a real example here. And to do that, I'm going to go ahead and go over to REPL. All right? Give myself some more room here. And let's go ahead and usually I do Husker scores because right about now we would be having our first game coming up or something like that, but unfortunately no. So we're going to do something else. Cubs score. Right? And we'll say that the Cubs tonight, well, they'll start playing in a half hour here, so don't ruin what happens. Let's say that they have an outstanding night and they score 10 runs here. They're playing the Tigers. Tigers score. And let's say that, well, they're typical. They were atypical last night and scored a lot. But let's go ahead and say that they score 3. Okay? Who won? Or let me go ahead and say, we don't know these scores yet. We'll read these scores as input to our program. Okay? In other words, we'll go ahead and go a to I of argv sub 1. And, because you can't score 1.5 runs, a to I of argv sub 2. And if I'm going to do that, I'm going to go ahead and take it over to CS50 here. Let's go ahead and create a new file. Game score.c. There we go. And I'm going to cut and paste the basics over here. Oops. I need more. There we go. And there. Now I've got an actual program here. Make sure to close this off and return 0. We'll read those in as command line arguments instead. Okay? So, who won? Without knowing the score because the game hasn't happened yet. How can I write code so that when I do have that information and I can input it into my program, that I do end up with an answer that, oh, the Cubs won because they scored more runs. Oh, the Tigers won because I forget who's starting tonight anyway, but they had a terrible start, right? I can make if statements. Now, what condition would I want here if I wanted to detect whether or not the Cubs won? Printf, Cubs win. What condition should I put in here? Just in English. If the Cubs score is greater than the Tigers score. Right? And there's our first condition. A less than sign. Now in this context it does mean, greater than sign because we're reading it left to right. If we can have greater than, we can have less than, we can have less than or equal to, and we'll get to that here in a moment. Otherwise, else if the Cubs score is less than the Tigers score, or Tigers, sorry. I should have Cubs up here as well. There we go. Then what should I print? Who won then? Tigers win. No. There we go. Okay. Else, what's the other possibility? So if I've got just two integers, one can be greater than the other or vice versa. What's the other possibility there? It's a tie. Else if, how would I do that? Cubs score is equal to the Tigers score. There's a preview of how you do this. Equals equals. Why do I need to use two equal signs? Because equals is already being taken up by something. What is the single equal sign for? the assignment operator that I'm using up here. Take the thing on the right-hand side and put it into the variable on the left-hand side, which is forcing us to use these two equal sign here. But do I really need this? Is there another possibility? Printf tie. There are no ties in real baseball. There are ties in certain baseballs, but not real professional baseball. You keep going until, oh, well, there are technically, there can be ties, but that's just because they get to the end of the season and they can't make up the game, and so they just call it a tie or something, right? So, yeah. Right? That's not real baseball, though. Do I really need this condition here? What are the three possibilities of scores? One team wins, or the other team wins, or the tie. Is there another fourth possibility? No. So this is cruft. I don't need this at all. I can get rid of this. In fact, I still have cruft here. Either it's strictly greater than, or it's strictly less than, or it's equal. Do I really need to check for that? No, that's the default. Okay? So let's go ahead and compile this. And of course, segmentation fault because I didn't provide enough command line arguments. We now know how to deal with that, right? Because I've got if statements. A.out, let's say that the Cubs score 10 and the Tigers score 3. Yay, Cubs win. Let's unfortunately say that the score was reversed, 3 and 10. Tigers win. Any baseball fans at all? All right, fine. What about 3 and 3? Then we would be going into extra innings, or in this case, we would just print out tie. Okay? Those are the only three possibilities. And this is only achievable with an if, else statement. And only one of these gets executed. You saw that there's only one possibility here for that either this gets executed, or this gets executed, or this gets executed. No other combination of those three pieces of code gets executed. Okay? I'm going to go ahead and cut and paste this so that you have it in the notes if you need it. See, there we go. There, that's in the notes now. Any questions online? Okay. So, we've already seen one type of comparison. What are the other types of comparisons? Numerical comparisons. Right? You can compare two values, either variables or literal values. In other words, hard-coded numbers. Is A equal to 10, or is A greater than 10, etc.? Using various comparison operators, right? And I'm going to emphasize this here, numerical values. In fact, I'm going to super emphasize it. These can only be used for numerical values. You cannot use these for other things, okay? The strictly less than, right? You can also do strictly greater than. Let me reformat that. Come on. There we go. All right, and this is strictly greater than. Right? You also have, we've already seen equals equals, right? We'll talk about that in a second here. But how would you do less than or equal to? So we don't have the luxury of having nice mathematical stuff that looks like this. Oh, come on. There we go. Less than equal to or greater than equal to. All right, that's not showing it up at all. What the heck? All right. Oh, wow. Bunch of stuff got broken here. I'm going to have to close this and restart it. Sorry. Open a new window. There we go. All restored. Don't worry. And zoom in a little bit, maybe. There we go. Okay, there we go. It choked on those for a second. Oh, it's choking on it again. Okay. Sorry about this. Anyway. Okay, at least it's still going here. So in mathematics, how would you draw the less than equal sign? Less than, and I'm tethered, less than or equal to, right? Do you see that on your standard QWERTY keyboard? No. So what do we have to do to approximate that? Less than or equal to, right? This is less than or equal to. And, of course, you can have greater than or equal to, right? And the order there does matter. You don't write, let me go ahead and just write it really quick here. You do not write, equal to or greater than. Some languages do allow you to have that, but that's not an equal to or greater than. What does that look like now? Looks like an arrow. It's a right arrow, right? Or, nor, do you write less than or equal, sorry, you do write that. What else? Greater than or equal to or less than? Yeah, that just looks weird. What is that? That's an angry guy, right? That's one of those ancient smileys. That if you actually type that on your phone, what would it come out to be looking like? Like an angry smiley now? All right? So we don't write those things. Instead, you need to write it like it said. Less than or equal to, greater than or equal to, right? You also have strict equality, right? This is equals. And again, the reason that we need two equal signs here is because they decided a long time ago that with a single equal sign has a special meaning, that it's the assignment operator. Take the thing on the right-hand side and put it to the variable on the left-hand side. All right? This is strictly equals. So now how do we get not equals? Well, if you were in mathematics, what would you write? Equals, and then you just put a slash through it, right? We don't have that on our keyboard. So the best approximation is an exclamation point in front of an equal sign. This is not equals. Right? This is the inequality comparison operator. Right? All of these operands operate, all of these comparisons only operate on two values, and all values must be numerical. Right? Or on two operands, I'll say. Right? And I'm making that change because operands can be variables, literals, or even expressions. Right? So let's take a look at another example over here. I'll go ahead and get rid of all this since we already have it in the notes. Let's go ahead and make some comparisons here. A is equal to 5 and int b is equal to 10. Okay? And let me just go ahead and give myself another variable here, 15. Right? C is 15. If A is, I can do a comparison with a literal value. A is equal to 0. If A is equal to 0, then I'll output printf A is 0. Don't divide by it, or else, right? Do something else then, right? That is a variable being compared to a literal. Now you can write something like this. You can, but shouldn't, do the following. If 0 is equal to A, right? Printf, well, it's the same thing. I'll just go ahead, copy and paste. There we go. Those two pieces of code are exactly the same thing. In effect, which one is more readable? Which one's more natural? Right? Would you ever read it like if 0 is equal to A? That sounds weird. Right? If A is equal to 0, that sounds natural. So if you ever have a choice of a variable, a variable being compared to a literal, then write it variable on the left-hand side and literal on the other side. Right? You can, but you shouldn't do it the other way around, just because it sounds weird. Right? You can compare two variable values, like we already did. If A is equal to B, then printf equal end the line, or else printf not equal, and then end the line. Right? You can also compare variable expressions, right? You can use expressions. Right? So for example, if the square root, or actually, if b times b minus 4ac is less than 0, then what's going to happen if we try to compute the roots of a quadratic equation? You'd get an odd number. So printf, you have complex roots. Right? And then we can choose to quit out of the program or do something else or something, or maybe compute the change the sign and then take the square root and then handle I by ourselves somehow, some way of doing it. But now you have an expression. That entire expression there is going to be evaluated. It's going to multiply b by itself, then it's going to multiply 4 times a times c, and then it's going to take the difference between those two. That's going to have some sort of a value, and then it's going to be compared to 0. And if it's strictly less than 0, then you know that it's negative, and you know immediately that that you're going to have complex roots. You can also test for even or odd. How would we do that? How can I test if a is even? If a is even, then printf even, or else print odd. Can I do that? Is that proper C code? No. How can I test if something is even? Well, if I divide by 2 and it's even, what's its remainder? 4 divided by 2, remainder of 0. If I have something that's odd, 3. 3 divided by 2, what's its remainder? 1. So if I divide by 2 and I check to see if that's equal to 0, then I know that it's even. Otherwise, I know that it's odd. And I can do whatever kind of expression that I want over here. Okay? Cool. You can, but you shouldn't. You can, but you shouldn't do the following. This is cruft. If 10 is equal to 20, then printf, okay. Or if 10 is equal to 10. I meant print 10. There you go. Printf, yeah, okay. All right. What's going to happen there? On the first one, is okay ever going to print ever? No. Is 10 ever equal to 20? No. This is what's called a contradiction. Something that is never true. This is dead code. This is cruft that should be taken out. You can, but you shouldn't do this. It's just, it's nonsense code that hopefully a good compiler will actually optimize and take it out anyway. What about this? That's not a contradiction because it's always true. Something that's always true from philosophy and from logic, we call those tautologies. Right? This is a tautology. There's your word of the day if you didn't know it. Tautology. Something that is always true. Right? So don't do that. Right? If you want this piece of code to execute, yeah, okay. Just put it over here. Right? There. Now it's a positive. Right? Remember, up here I was saying, yeah, okay. Right? That's a negative. But the exact same words in its different phrasing. Yeah, okay. Right? Now it's okay. Now it's a positive. Right? Do that instead. Okay? All right. Let's see. So going back, you know what? I need to cut and paste this so that you have it in the notes. If I ever forget to do that, please let me know because then it won't be in the notes. There we go. And now it's over there. Okay. Do we want to run this program and see what happens? I think we predicted everything correctly. You can run it on your own if you want. It's just a bunch of examples. Okay. So some pitfalls here. Pitfalls are common errors or misconceptions. You cannot use numerical comparison operators operators for strings. Right? I'm going to show you an example here. So I'm going to get rid of all of this. And I'm going to create, we haven't talked about strings yet. So I'm just going to create two strings here. Hello equals hello. Well, are those two, we know about strings as in we can use two double quotes here to put in strings, to put in a message and print that message out. You can also use those as variables. I'll show you how to do that when we actually talk about strings. But I want to show you that you cannot use the comparison operators for these things. It'll compile, it'll run. What'll it do here? Printf, the strings are the same. Right? Well, are they the same? I called this game score, but it no longer has anything to do with games. So are those two strings the same? H-E-L-L-O, H-E-L-L-O. They look the same to me. The strings are the same? Okay, fine. I'm going to have to force this then, sorry. Don't worry about this. If char high is equal to this, ignore what I'm doing for now because we're not there yet, but this is conceptually the same thing here. Right? So this variable is a string that holds the value HELLO, and now I'm saying, is that equal? Right? And it prints out nothing this time. No, they're not equal. Right? Else, I'll explain why it screwed up the first time. Printf, these strings are not the same. Right? And let's go ahead and execute this again and show you that indeed it's saying that the strings are not the same, even though they're both capital H, E-L-L, lowercase E-L-L-O. Why is that? It's because the equals operator in C is only operating on memory addresses. This is a string that's stored somewhere in the computer's memory. This is a string that's being stored somewhere else in a computer's memory. And so, of course, when I ask, are these two things the same thing in memory? It's going to say no, because that's a memory address XYZ. That's memory address STU, right? Those are not the same memory addresses. And so it says that the strings are not the same because the memory addresses are different. The first example that I was not able to get to work was because it was a tricky compiler saying, hey, wait, you just compiled two strings exactly the same thing. I'm not going to make two strings in different memory. I'm going to optimize that and make those the same strings. And in fact, it probably optimized everything away for me anyway. Right? That was just under the hood compiler magic. But the real takeaway here is that you cannot use any of these operators for, this might be true actually, for strings. Don't do it. Now they're not the same. Okay, good. Right? They're somewhere else in memory. So again, the takeaway is numerical comparison operators end up, when you use them for strings, comparing the memory addresses of those strings. And it will not give you the correct results. It'll just give you weird results. The general negation operator. Any statement, any logical statement can be negated. Right? True, negated. Is that right? Yeah, that should be right. True becomes false, and false becomes true. Right? You do this using the single exclamation point. Right? There we go. There we go. Right? Example. So suppose I wanted to negate A is less than B. It is not the case that A is less than B. Right? So you can write something like that. But should you? Or here's another example. A is equal to B. I'm asking, are they equal? Well, I can go ahead and say, negate that and flip it and say, well, are they not equal? Are those the best ways to write those two expressions? So there's another acronym that you should probably be familiar with, KISS. And it's used it's not just used in computer science and coding. Keep it simple, stupid, right? Telling yourself that you're stupid. Keep it simple, keep it simple. Are those the simplest ways of doing those things? If A is not strictly less than B, then how do I express the opposite of that? Right? better to use. So if I negate, well, let's take the second one. What about the second one? What's a better way of writing? It is not the case that A is equal to B. Right? Even in English, there's way too many words there. Cut down those words. It is not the case that A is equal to B. A is not equal to B. Right? So we would write A is not equal to B. Right? That's a much more compact way of writing it. What about the first one? If something is not strictly less than, then what is it? A is greater than B? Is that correct? Is that the opposite? Careful. Think about the number line, right? Greater than or equal to, in fact, if I were to write it down, greater than or equal to, say, A, well, I would fill in that dot, right, because I want to include A, and then I'd say everything above that, right? Well, if I want everything below that, what do I do with that dot now? I don't fill it in. So the exact opposite would be greater than or equal to, right? So be careful there. It's better to use those expressions. In general, write the simplest form of an expression. Right? Simplest is best because simplest is easier to understand. And here's another slang term for you. Simpler, here, I'll write down KISS for you. Keep it simple. And then you can call it, you can use stupid or I don't know, stud. Give me a positive S word. Super. All right, there we go. Instead of stupid, I'll just keep it stupid. It's me. I'm the one keeping it stupid. All right. Keep it simple, stupid, is KISS. There's another word term that I like to throw about because you'll eventually see it if you do a lot of coding. At least it's in the coding culture. Grok, right? Simpler code is easier to grok. Grok is a slang term from science fiction. It's from a book called Stranger in a Strange Land by somebody online can tell me. Anybody? Darn it. Stranger in a Strange Land. Author. Come on. Can't just preview it for me. Heinlein. That's it. It's Robert Heinlein. And in it, he coins this term. It's actually, I think, a Martian term. Grok means to understand something. So do you grok it? Do you understand it? I like to throw as much, introduce you to as much slang as possible, as much jargon, because eventually you'll see it and like, what the hell is that? And then if you already know it, then you can sit at the cool kids table or something. Cool would be the last word that I would think about with that, but I'm at whatever table you want to call that. All right. There's also, you can use also boolean variables with these kinds of expressions. You might be familiar with some programming languages that have boolean variables that can hold a value of true or false. C actually does not have one of those. C does not have the keywords true and nor false. Now, you can bring in a library to do it, and in fact, I think it's boolean.h. You can bring in that library, and that defines those two keywords, true and false, and you can use those all over the place. I think that they might be case sensitive, case insensitive, I forget. But in any case, I rarely ever use them. Instead, C does not also does not have Boolean variables. Right? These are variables that can hold a value of true or false. Right? Because there is no true and false in C. Instead, in C, false is 0, or actually, and anything else, right, positive, negative, etc., is true. Right? So the convention that they used in C was to not define a brand new variable type. Instead, you can use an integer type. Int is student. Right? For example, let's go ahead and go over here to our IDE and start playing around here. What I can do is I can create a variable called isStudent. And we can set it, ideally in a programming language like, say, Java or PHP or something like that, you could do something like this. True, they are a student. Or false, no, they're not a student. But in C, we can't do that unless we bring in a library to do it for us. So what we have to do is, if I want to set it to false, set it to true. Actually, let's go false first. What would I do? IsStudent is equal to, what's false again? 0. That's the only thing that's false, right? There is no other false value. Set it to true. Well, isStudent is equal to 1. That's typically what you do. But it doesn't have to be like that. You could set it equal to 2, or you could set it equal to 42, or you could set it equal to -1, right? All of those things are true. Why is it that way? Because of negation, right? If I negate a false value, it has to necessarily, a 0 value, it has to necessarily become a non-zero value, which means positive or negative. If I negate a positive value, positive or negative value, it just can't become negative. It has to become 0. And that's what we use in C. By convention, of course, you can go ahead and just use 1. Right? But all of those things could be true. You could set it equal to 42 if you wanted to. Now, internally, if you do bring in that boolean library, then I believe that it will be used 0 and 1. But that's just one convention. It doesn't always have to be that way. Okay? So, how do you use these variables? You can use them without an expression. So if isStudent is true, then we'll go ahead and give you a student discount. Where do you get student discounts? Movies are closed, unfortunately. What is open right now that you can get a student discount out? Tell me how the world does not suck right now. Amazon. Okay, you do? Okay, cool. Here's another example. If you signed up with GitHub with your .edu account, then you get a bunch of free stuff from GitHub. So if they're a student, then we'll go ahead and print you get free GitHub stuff. Right? Else, me, actually, I don't care about the free stuff. You gotta pay for that because you're not a student, right? If else statement here. All right. So this is not real C. If isStudent is true, remember we don't have the keyword true here unless we bring in a library. And certainly we don't have this kind of English here, is, right? So what do I do instead? One way that I could do this is say, if it's equal to 1, okay? Now when I run this, GCC game score, then remember that the last thing I set it to was true, and so it'll print out. Yay, you get free GitHub stuff. If I instead set it to false, and I'll go ahead and get rid of this, then compile it and run it, you got to pay for that, right? Because you're not a student. The problem with this is the fact that C does not necessarily use 1 as true. Remember, 42 is true. So they are a student. What is it going to print out in this case? If I run this, is it going to print out that I get free stuff? No, you got to pay for that. Why? Because isStudent is equal to 42. Even though it's true, this expression is wrong, right? So how can we make this right no matter what we use for true? If we use -1 for true, +1 for true, 42 for true, 3.5 is also true, right? An A is true, right? Because A has a value, an ASCII text value of 65, capital A does. And so that would be true, right? How can we simplify this code? By getting rid of that cruft, that unnecessary stuff. If they are a student, right? If isStudent, so this is kind of bad to read it like this. If isStudent, right? It sounds like a caveman. If they are a student, but don't worry about grammar, all right? Just use, when you look at it by itself, is student, that makes sense. So that's a good variable name. This is a bad variable name, our student, right? Now that sounds like a caveman. Don't do that, right? Is student. Just use the Boolean value itself. This is either going to be true, false, or it's going to be true. Just use that as a simplified expression, okay? All right, I'll go ahead and cut and paste that so you have that in the notes. There we go. All right, and I'll bring over what we did here. There we go. Again, to recap, in C, 0 is false. Any non-zero value, 1, 10, 3.14, negative 4.5, those are all treated as true values. When you assign a true value, then you use a 1, but you cannot assume that true is always a 1. Therefore, when you use a Boolean variable, make sure that you generally want to use an integer, because if you use a floating point number, there is such a thing as negative 0, and that is not 0. It gets weird. All right, so just go ahead and use an integer, and then when you use it, just use the actual variable in an expression. Don't say, is it equal to 1, or is it equal to 0, right? Just use the variable itself, right? Okay. Or what would you do if it was a negation? How would I negate that? If they're not a student, then do something. How do I do not a student? Is student is my variable, right? How do I negate that again? Exclamation point, right? Exclamation point. Okay. All right. With about 10 minutes left here, or about 9 minutes left, I guess, let's go ahead and talk a little bit about combining into more complex statements. So complex logical expressions. Right? You can combine one or more logical expressions using logical connectives. Don't worry about the fancy word there. You've seen them before. All right. The logical connectives are and or. Right? And those are not C keywords. In some, like in Python, you would use the English and or. In C, the logical and operator is true if and only if both its operands are true. Right? We use the ampersand. Now, why do we do that? Well, what does ampersand stand for? Like if you saw a law firm or something, Simon & Schuster, do they write out the word and? No, they get fancy. What do they write? They write out an ampersand. The ampersand means and, right? Why don't we just use one? Well, you can, but that has a different meaning. It's a bitwise logical and it operates on it's something called bit twiddling, where you can actually start to manipulate the single bits in an expression or the single bits in a number. We won't get into that into this course. Just know that you have to use two logical ands, the ampersand to get that. So for example, you can say is student and is freshman. Then is true if and only if the person is a student and they are is both the person is both a student and a freshman. If they are a student but they're a senior, then it's false. If they are a freshman but they're not a student, then that's weird. But then that is certainly false, right? Both of them have to be true, right? It's false. False when one or the other or both operands are false, right? The logical, the brother of this one, the logical or operator, and again, we don't use the keyword or here, is true if if at least one of its operands is true. Right? In C, we use the, oops, sorry, I didn't hit my shift button there. What does anybody have a name for those? Does anybody know what those are called? They're on your keyboard. They're right above the backslash. You have to type the shift and then the backslash to get some people call them vertical strokes. Some people call them pipes. Some people call them Sheffer strokes. It depends on the situation, depends on the context in which you're using them. So there are lots of different names. In computer science, especially if you're from a Unix background, we just call them pipes, right? Or vertical lines, whatever. Right? It's the OR. And by the way, there is a single OR. That is a bitwise OR. It's not something that you want to use because it won't give you the same behavior that you would be looking for with a logical OR. You need two of them, just like you need two ampersands. All right? So for example, is student or is freshman? There. Now that student that was a senior before, they're not a freshman, but they're still a student, so this evaluates to true. Is true if either of the conditions is true, or both. So this is a little bit different maybe than what you're used to, because if say a mother tells a child, you can have cake or ice cream, this is not the same thing. What is the mother saying? You can have cake or you can have ice cream, but you can't have both, right? Because you'll spoil your dinner or whatever. That's called an exclusive OR. So it differs a little bit from the English OR, because or in English sometimes means exclusive OR. You can have this or this, but not both, right? You have to add that at the end to be really clear that you can't have both. But in this case, it can be both. That student that is somebody that is a student and a freshman, this will evaluate to true. Somebody that is a student but a senior, this will still evaluate to true. Somebody that is a freshman but not a student, again, I don't know that that can happen, but let's say that it does happen, and that would evaluate to true. Both of those would have to be false for it to be false. It is false only when both of the conditions are false. Otherwise, it's going to be true. Okay? All right. Any questions online? No, you cannot. So, good question here. Let's try this out. The question was, can you not use the following? Let's see, option and equals. Option equals. There we go. Oh, cool. So you can get that, but that's not ASCII text. What is that? Let's ask the World Wide Webs what that is. Unicode value. So that has a Unicode value of, there we go. Is that not equal? Nope, that's the equals. And wow, my browser can't even distinguish between equals and not equals. Weird. There. That's the Unicode character. What value did it have? U266X, or 226X. Definitely not ASCII text, right? It is way up here in the mathematical symbols table. That is not ASCII text. You would not put that in code. In fact, if you tried to put that in code, I can put that over here in my markdown editor, but if you tried to put that in code, let's find out. Let's go with I'll go ahead and get rid of all this since I've already did it. Int A is equal to 10. Int B is equal to 20. If A not equal to B. This is so stupid. Printf. Okay. Yeah, this is definitely not going to work. This is probably not going to compile, I imagine. Yeah. It doesn't have any idea what that character is. In fact, you can see it trying to understand what the hell that character is. It expands out its Unicode value, and that's what it tries to interpret it as, garbage. You cannot use Unicode characters in most programming languages. Some programming languages you can. So if you've got, like if your first language is Chinese, then you can start typing variable names in Chinese in, say, Java, right? But you cannot do that in C. Right? You can't do that. You shouldn't do that in any programming language, but you can do that in some programming languages. Okay? Any questions? Otherwise, that was the only one online. How many people we've got? 53, down to 53 now. Right? So we're going to give it another couple of weeks here, but it looks like the first time only 16 people came. This time only face-to-face. Same thing seems to be with the labs. Only 12 people came. This room can fit 53. So if the trend continues, then we could change our schedule so that potentially in the future, so that we could have you coming every other time based on your NUID or something. So if you're interested in that, go ahead and post on Piazza, and we'll consider that in the next couple of weeks. We'll see how the trend continues, and we'll also see whether or not everything gets shut down or something. Anyway, all right. Have a good hack session tomorrow, and I'll see you next week.